My name is Ruben Hamers. I am indeed from the Netherlands, an echte Nederlander. I'm here to present Discourje, which is a library to automatically validate message exchange patterns in Clojure. It's part of my MSc thesis and an ongoing research which aims to simplify concurrent programming. So a little bit of background information. I've always been very interested in concurrent programming, so its difficulties, its benefits, and also the solutions. So I searched for a related topic for my MSc thesis, and I found this research which uses languages like Java and C and even JavaScript as their implementation language. So since they were already targeting the JVM, I thought, why not use Clojure, since Clojure is designed for concurrency. Like we have mutability for free and the SDM, software transactional memory. And something else really interesting is the seamless interoperability with Java, which allows us to interface with the existing research. A topic in this research are these message exchange patterns. And they are used to specify a communication pattern as a validation mechanism for synchronization among threads. So Clojure can offer us some help specifying such a message exchange pattern. But first, I'll show you an example of such a pattern. So this will be a message exchange pattern in a language called Scribble. It represents the use case of ordering some product. So we can see it has two participants, a buyer and a seller. First communication in this pattern is a quote request from the buyer to the seller, in which the seller can either respond with a out-of-stock message or he can continue on ordering his product, which will end with an acknowledgement. One thing to note here is that this language looks a little bit like Java or C, but it's not. It's Scribble, which means that developers need to learn a new syntax and new semantics. But more importantly, there must be some compiler of some sort to turn this language into something executable. And this is where Clojure can offer us some help. So I talked about how Clojure is designed for concurrency data, but also it brings flexibility. So Clojure being homo-iconic allows us to bypass this need for a special compiler completely. So we can define macros to specify such a message exchange pattern through domain-specific language using these macros. Core.async in this regard offers some very useful utilities, since we are trying to communicate among these threads through channels, so it matches the design of Core.async. Another thing is that in this particular research field, there has never been done any research towards embedding such a language as a domain-specific language. So there was also an opportunity to do something really new. So I started off by designing my own framework of channels and send and receive abstractions using just default Clojure code, refs, agents, atoms. But then I found core.async, which solves this problem for me, so I quickly adopted this. Interestingly, I found a blog that states that unlike other Clojure concurrency constructs, channels like all communications are subject to deadlocks, which is something Rich Hickey wrote in this blog, 2013's blog. So we want to add some validation to this to be able to not run into these deadlocks. This is where Discourje comes in. So it extends core.async channels and operations with validation logic. So it monitors the communication between those threads. And when incorrect communication is detected, you can throw an exception and act according to it. And it's all done through a special DSL, just to specify these map frameworks. Before I show some examples, quickly to support the features. So we have atomic send and receive operations, which specify an interaction between A to B. We can put them in sequence, we can put them in parallel. We support branching a specific way based on some interaction. which is the example like our stock branch or the continuation of the ordering. We support recursion as a looping mechanism, and we can nest branching and recursion arbitrarily. So we can make any combination you want. So implementing Discourje takes about 3 steps if you have a core.async code. So the first step would be to define this message exchange pattern. So this would be the buy goods example we saw earlier in Discourje. So there's this first communication, the quote request from the buyer to the seller, and then a choice with 2 branches identified as vectors, which are about the shortest way to write it. So square brackets represent the branches. We can see the outstock branch and the continuation branch with ending with the order acknowledgement. So step 2 is to generate some infrastructure based on this message exchange pattern. So we generate only the channels we need to communicate. We can allow Discourje to do this for us, or we supply our own custom channels where we can differ in buffer sizes. Step 3 is to communicate through Discourje. This will be some code representing the buyer's perspective. I'm not going to explain this in detail since we got time for that demo. So I prepared a couple of source files representing step 2 of 1 till 3. Beginning with step 0, which is I prepared 4 source files, so step 1 to 3, and step 0, which is some default core.async code. So let's first explain this. So some namespace imports. I define some channels of the project. Sorry? Thanks. I didn't think of that. Where were we? So we define 2 channels. We have a product, in this case a book, an in stock function, which is a simple function where true or false with a 50% chance. Some logic representing the buyer, logic representing the seller, and we start both functions on different threads. How do I exit there?
See, how many programmers does it take to get out of there? No, it's a double shift and then you can type anything in IntelliJ.
There we go again. So for the demo, we used Java objects as our message types just to illustrate the interoperability to Java. So step 1 is to define this message exchange pattern. It's the same one as we saw earlier. So it's just the buy goods example with the quote request from the buyer to the seller, and the 2 branches representing the out of stock and the continuation. Then we see there's 6 lines not compiling, which are our channel definitions and our take abstractions. So let's first fix those channels, which correspond to 2. So instead of defining our own channels, we will get our channels from the infrastructure, which we defined earlier. So we query the channels from our infrastructure, and then we can use them in our code. Step 3 would be to implement the take abstractions. So when we are communicating through Discourje, we need to identify each operation being used. So when we are taking from some channel, we do not know what we should be taking, so we need to supply some label, some identifier. So we will identify ourselves as our message exchange pattern specifies. So in this case, they are Java types, which we are using in our take operations right there. Future work. I would really like to add some more supportive features for core.async. Currently, we only support some standard channels and blocking take and good variations. We would really like to add Go blocks and the non-blocking variations. Maybe pipelines and multi-channels. Also, compile time validation of the message exchange pattern. I think we can spot problems earlier if you do some compile time validation, and Clojure spec just to make our public interface more robust. Conclusion, Discourje offers separation of concerns. So we are able to specify this message exchange pattern separate from our implementation, in which we are able to improve readability and maintainability, and acts a little bit as documentation. It's built at DSL, so no special compiler or syntax, just Clojure. It protects against communication mismatches and deadlocks. Are there any questions? And notice the recursion, which we did not see in the note.
Thank you, Ruben. And I know it's nerve-wracking when other programmers are looking at when they're trying to code and there are like 120 people looking.
That's why I prepared some source files, but apparently did not work as perfect.
Thanks a lot. We're going to hold off for the. Yeah.